Good morning.
Hey, good morning, doctor. Good
How are
morning.
you?
Hope you're good. Yes, I'm good.
Any questions so far?
No, doctor, I'm very much satisfied and I'm making my final project submission. Maybe in
Okay,
2 3 days, I will be submitting
okay,
that one
okay. So
along with it.
what topic are you working on right now?
I'm working on the how to use this robotics in the chess format.
Okay. And then how much progress you have?
Um, Now I just need to work on the arms. By using the matplot, what you have told suggested me in the last class. So I'm
No.
working on that one.
Okay, okay. Yeah, just do your best, okay? Try your best.
Yes,
And then
yeah, definitely, doctor. I will try my
make
best.
sure it's a project that you can impress the interviewer. If in the future you need to present some university project to find a job, right? That's actually the whole purpose of preparing a term project in by yourself and finding a project. So if you did not complete everything, or you think that there are something you can still be expanding after this the final, okay, after you submit it, you are supposed to continue to work on it, build a much bigger project until someday someone actually interview you and you have something you can talk about.
Yes, my main focus, I am also doing that only, doctor, and it is helping
Yes,
me a lot in the time of making reports and making
yes,
my PPTs. I have just started for PPTs, so
yes,
it's
yes.
raw, so I'll make
Making
it.
sure those are presentable when you are, trying to find a job. Okay. So, are you looking for a job soon or no?
Sorry, sir?
Are you looking for a job soon or no? When are you going
Yeah,
to graduate?
I'm going to graduate in the May 24,
Oh,
and
okay,
one more
okay.
semester I have. I'm looking for some kind of internship, doctor. I would like to ask you many times, but I couldn't.
Yes, yeah, you can ask right now. Yeah, before we have other student meeting. Internship, you must pass. Maybe right now a lot of internships very difficult. Maybe 4 rounds, 5 rounds, or even 6 rounds of the interview. Okay, some are behavioral interviews, some are technical interviews. Technical usually right now have 2 rounds. One round is the code online code test, right? Coding test, and then there's
Yes.
another round of the human technical interview. Online testing usually is 1 hour or 45 minutes. You solve 4 problems, and you usually need to solve 3 at least, and or you need to solve all the 4 problems depending on how your competitors are. Okay, and then that's a second round, usually second round. First round is that is a human resource people will contact you and talk about your background check. Okay, so that's first
Yes.
round. Second round would be coding test and test how good you are in decode or something, right? Those are coding tests.
So,
Third round,
mhm.
yes. Question?
No. So, sir, always my question is, I work on DevOps before I started masters after completion of my undergrad, but I don't have any experience on this machine learning and these things. I'm just learning and doing my assignments. So, at the time of interviews, how can I convince them just like I'm the beginner in this field in machine learning in AI?
They don't take beginner in this field.
Okay.
They want you to be ready. So
Okay.
the way that if you finish the master program and still not enough, my suggestion is that you still need to take more courses, even online, Coursera or something.
Yeah,
Okay,
I'm learning. Yes, doctor.
you must
So,
actually try to do it, and then if you don't have the related internship, you can just even summer internship, they are free. Okay, no
yeah.
pay internship. You should
Yes,
take it.
yeah. Okay, I'm good for the free also, doctor.
Yeah, and just do those free internship. Don't waste your time. Don't just stay home waiting until interview comes and then I must get the high pay job. Okay, if you have that mentality right now, it's very hard to land
Yes.
a high pay job right away. The competitive, all the competitors are very strong. Okay, all the competitors are very strong. You have to fight through it. So that's the problem. And then recent few months or 1 year or 2 years, Bay Area laid off a lot of high quality engineers. Okay, because of many
Okay.
reasons, downsizing the company, any reason, okay, whatever reason they are. So in the market right now, there are a lot of good engineers, senior and also experienced engineers around. So the competition is really high right now. So you have to prepare yourself well.
Yeah, I'm going for, I mean, like I'm taking classes in Python. I know Python, but however, for the interview and for the job, I'm not ready. So I'm
Yes,
going
your
for Python,
coding in
PyCharm.
Python must be able to pass the LeetCode, at least one easy problem, two medium, and one hard problem. If you go to the interview, okay, usually there are four problems. Some may be too medium, too hard right now in some company, but usually it will be one easy, two medium, and one hard. You need to pass at least three problems. The last one you must also be close. So your programming level must be more than the medium level in LeetCode. If you cannot handle the medium problem, then that would be a problem. So usually we suggest that before any interview, even the internship interview, you must practice more than 150 LeetCode. That's at least 150 LeetCode problems. That take quite a lot of time, maybe at least 3 to 6 months as a minimum. Yes. And then if you want to land a high quality job, maybe 300 LeetCode problem. That's typical. So that is a lot of time. So you should start the LeetCode practice right now, not wait until you graduate. Okay.
No, yeah.
You should keep doing it right now, and then at the same time you can take some internship. You can take some internship even in school year. You can take some no pay internship. Okay, and then you can also try to take courses and then to pass the machine learning certification from, say, let me show you the one that my son took.
Yes, okay, sir, please.
Okay, there's you can take the Amazon AWS certificate. Okay.
Oh, okay.
So there are many certificates that Amazon has. Not only one, there are many. Okay. There are many, and there are some starting one, some more. Let me see, some more. Let me check if there is a certain image. So this is a certificate, but I want to find some image, the flow chart. Okay, these are easier. So this one is good. Okay, this one. Okay, this chart is good. So this one, let me see. Let me zoom in a little bit. Okay, you can find the Amazon certificate and find image. You should find this one. So you need to start it from AWS Cloud Practitioner. Okay.
Okay,
and then start to look for architect, operator, or developer. And then also there is one very important one, AWS machine learning, this one. Okay, if you get this one or you get this big data, usually these two or security, it will be very easy to find some job. Then you are well prepared. Okay.
Okay,
So
doctor.
this one very important. Let me actually just copy this link. So
Tem,
before
tipo,
you
desse do Blue Plant, que tem dessa Web IQ, é difícil eles migrar, mas é bom a gente estar em cima, porque uma pisou na bola, ou o preço também, né? Aí quando vê
hello.
ele, né, não vou dizer que não é amor à camisa, mas não tem obrigação, né? Tipo, tem que vender
Hi Bruno, can you
vender
mute? Hello.
o Web IQ, né? Entendeu?
Hi, Bruno, can you
Entendeu? Quem
mute?
tiver mais competitivo e fazer mais sentido, né?
Hello? Okay. So these are the certificate you can get, or you can get the certificate from Google. Google has it's all. You just try one of the Google, Amazon should be good. Okay.
Okay, doctor. Thank you so much. I'll do it.
This side, the left side is Amazon Web Service. So this is more like cloud computing. Okay, it's more like cloud computing. In addition to the cloud computing, there are 3 levels: foundational, associate, and professional. If you reach the
Aí que é
professional,
uma.
you will be
O que
very
que tu
easy.
fala
Hi,
pelo
Bruno, can you
Associate
mute
e
yourself?
Enterprise?
Hi,
Sim.
Bruno, can you mute yourself? Hi, Bruno, can you mute yourself? Hello? Okay, thank you. So this you have different level of the certificate. You need to go through it one by one. To take all of these, you may
Tá.
take 2-3 years, okay? But before you get a quality job, then you probably need to work on some job first, okay? Some serious job first, and before you can finish this and maybe change it for a better company, maybe even Amazon, okay? So that take some time after you graduate as well, okay?
Isso aí, isso aí.
Okay, so this is actually the certification, and then
Eu acho que teria as duas opções, porque essa poderia ser.
I mute him. Okay, that's this one is the certification, and also you need to make sure you take enough course in university before you graduate. Okay, before you graduate, and then you can have enough knowledge even to take the courses right here. Okay. Let's see what time it is.
Yes. Okay. Thank you so much for showing me, sir.
Okay, it's already 10:03. Okay.
Yes.
So let's get started. This is the last session we have. So before we talk about any topic today, let me still talk about a term project. Okay, this already we are in the last week, so we talk about the term project deliverable. Okay, we still want to emphasize one more time. Okay, what we needed, what we will need for this term project deliverable. So we need 3 things: a written report, a presentation, and a technical file, and all the technical files. Okay. The written report is to write down, okay, how you create this project, okay, and what's the reason you do this way, that way. Okay. So this final report will be a technical discussion of how you actually work on this project. Okay. And then how you execute the project, and what are the problem you face, and also what's the future extension if you have. Okay. And the presentation is just purely need to focus on what you have done. Okay. So don't give me too much history. I don't need history in presentation. So the presentation's main focus is what you have done on this project. So how your robot will move. Okay. And if you recorded the whole process of how you build a robot, that's also fine. Okay. And then you need to show me, if you are working on the modeling problem, you need to show me how your model work. Okay. That's all we need. Okay. And then how you derive the equation. Okay. Those are what we need. Okay. And presentation can be done in if you give me a PowerPoint file, that's fine. Google Slides, that's fine. Okay. And then if you can make a video, that's better. Okay. If you send me a YouTube link, that's better. But don't send me the MPEG-4 file. Okay. That's too big. I don't need that. Okay. I just need you to give me a YouTube link. Okay. And then finally, the technical file are the one that you generated. like program file, design schematic, whatever can prove that you actually spend time to work on it. Okay, then that's enough. So these are the final report, and we were grading this one. Okay, basically the final score is non-negotiable. Okay, and I'm very subjective. Every teacher is subjective. Okay, but we try to be neutral. Okay, we try our best to be neutral, but I don't think that there's a teacher that is not subjective. Okay, everybody has his own bias. Okay, but we try to look at your originality, creativity, completeness, technical difficulty, and the presentation. Okay, these are the criteria we look at. So don't copy. Okay, copy you get very bad score. Okay. No matter what you do and how good you have done, that's your own project. Okay, so we encourage you to be creative by yourself. Okay, and then original. Don't copy from other people. Okay, make sure you have complete the project as much as possible, and then we'll judge also on your difficulty and your presentation. Okay, these are some criteria we work on. Okay, so these are the what we have for the final. As for topic, we actually talked about it before. Okay, 3 possible topic direction. Okay, we don't force you to some project. Okay, anything about robotics will be acceptable. Okay, so you do modeling like this, drawing some diagram, and then writing some code. That's good. Okay, that's the first type of the project. Okay, so for this one, we really would look at if you are modeling a brand new robot arm, okay, or something. We don't encourage you to work on some robot model that we already covered in class. Okay, that's not good. Second one, if you want to build a robot, that's very good. Okay, and we will see how you build a robot and how good your robot works. Okay. And last one is the idea, okay? Idea, we judge on how new your idea is. And also judge on how much impact your new invention may be, okay? So these are 3 projects, okay? Why we pick these 3 project direction to guide you? That's because when we work on any invention or any robot, anything, the first thing we will ask is what's new. Okay. If you go to a PhD dissertation defense, the advisors looking at your project, only 3 things they'll check. Okay. Number 1, it is new. Do you have a new idea or not? If your idea is something that people already done, that's not PhD dissertation. Okay. The first thing is that new? Second one is that true? Are you copying, or is your story really something that will happen by your proof or not? Or your project is totally fake? Okay, you're claiming that you can you have a superconductor, but it doesn't superconduct. Okay, that's a problem. So we will check if that is true or not. Last one is that it is complete or not. Some people did not complete their project when they do PhD. So this one, we don't actually need you to be complete because it's just an idea project. So we don't need you to be complete. True or not true, very hard to judge. So this one we don't emphasize, but we do look at is that new or not. Okay, that's the most important part. When we judge the project we have on this course, okay, on this course term project. And we do not use the PhD standard to judge it. So I would just look at whether your statement that this new idea is possible is legit. Okay, it's something that may be a good direction that people can move on. So this one is really exploring the possibility of the robotics. Okay. So usually that's before a project is formed, that's brainstorming. You need to come up with idea, right? After you have idea, second phase, you try to model it and simulate it. So you need a math to model it. You need Python to build a model and simulate it, and making sure that the project is feasible and controllable. Okay, that's the second phase. Third phase, you really build a project, build a robot. So that's the phase, build a robot, really build it. So this is our suggested project number 3. Okay, number 3. This is project number 1, the modeling. This is project number 2. Okay, so if you work on any direction of this robotic project, would be what we suggested. But we don't force you to take one of these approach. If you have another way to prove that you know well in robotics, that's good. Okay, so that's why we suggest these 3 directions. Okay, that's why we suggest these 3 directions. But any project related to robot would be acceptable. Okay, I just want to see how much time you have spent on it, and then the whole purpose of doing this term project is to prepare yourself in job market. Okay. In a way, your project must be presentable. That you feel proud. You can present in front of your interviewer that I have done such a project in my university days. Okay. So must make it presentable. Must make it complete. So you will be persuading, will be able to persuade your interviewer that should give you a good job. Okay, that's the whole purpose of this term project. Okay, that's why we prepare in that way. 3 possible topics. That's actually representing the different stages of the ideas. Okay, and you actually work on that, and then you must make it presentable, especially must be helping your job searching purpose. Okay, that's why we actually have this project at the graduate level, and then wish you to do it by yourself. Okay, and we purely will be individual project. Okay, no group work. Okay, no group work. It doesn't mean that we don't encourage teamwork. It's just because that group work, usually we don't know who actually work on here for 40%, the other guy only 10%. Okay, it's very hard to judge. And sometimes you have 2 partners, sometimes 4 partners, sometimes 5 partners. We don't know which one, how. I mean, it's actually very hard to divide the responsibility and result. Okay, and also some students just don't participate enough. Okay, so we don't do individual work here. We are online course, so we don't actually encourage this project to be a group work. Okay, and because number one, we want you to be ready for job, right? So that's also a preparation for yourself. So we encourage the individual project by yourself, okay? And also we actually want you to go through the whole process of thinking and then forming the project and then execute it, okay? And getting result and present it. That's the whole process of the developing the project, end-to-end development. Okay. So if there are some group members, they take away your chance to create a complete project. Okay. So that's why we emphasize on individual project. But in a way, if you search for a job in the market, people ask you, do you like to work on a project individually or in a teamwork format? The answer always is, I can work on both way, okay? I can work on the project individually or in a team format. If I work on the project individually, I would be independent and also be a fast learner. I will pick up the knowledge that I need in the shortest time to be able to execute the project, and also I will be independently working on the project and searching for the resource. Okay, if I am given the opportunity to work in a team format, then I will be participating in the team meeting or the team organizing meeting a lot, and also I will be actually following the team decision and leaders' directions. Okay, and I have no problem to work in a team format. So that's something you need to answer when people ask you your preference of team project or individual project. Okay, usually that is the answer when you do the interview. But here we emphasize more on the individual work, okay, because we want you to be able to do it by yourself, okay. That's about the project direction and the term project, okay. Okay, so any other question about this term project here? We are in the final week, so I'm talking about the term project one more time. Any question?
No, that's good.
Okay, no question. I will just finish it here, okay? So term project, we are done. So try to enjoy it, okay? Let me emphasize one more time. The whole purpose is to prepare yourself to be job market ready, okay? You must make your project presentable in front of a group or interviewer, okay? That's the whole purpose. Okay, then the rest of the month, rest of the week, we are on the final parts of our course, okay? So let me bring up the lecture here, okay? So last time we talked about dynamic modeling. So you have the whole system you want to build. First thing, you need to use a mathematical modeling to model it, right? And then you create what is the actuator, what is the sensor, what is the feedback loop, and then what is the control planning part. Okay. Now next one is that you need to build a control loop. Okay, based on that modeling. The modeling must have some control loop. So that control loop you need to build it. There are a few approach. Okay. So we talk about the control before. There are different kind of control. They are high level control. High level control means that it's a computer. So you have a sensing result and you try to plan and you try to react. That's the top system level control. Okay. And those control is working on just like a computer design. So you may use a ASIC to implement it. You may use a CPU to implement it. You may use a GPU NVIDIA GPU to do AI control on it. Okay, whatever. That we already talked about the high level control. Today's topic will be low level control. Low level control is another control, but this one is module control. So, for example, you control the motor's velocity, your robot's driving system. Okay, then you need to have some controller. That's the controller we talked about before the actuator. Okay, so they could be a traditional control is PID control. Okay, I is integral. Okay, D is differential, P is proportional. Okay, so PI control. You may have P only, proportional control only. You may have proportional and integral. You may have proportional and derivative. You may have proportional, integral, and derivative, 3 in 1 controller. There are several types, and today we talk about the big direction of how these different PID control will work. And then, okay. So there are different results. We'll talk about this later. First thing is that mathematically, what are the PID controller? Okay. So let's assume that you have a plane point. So you have the temperature. You want to go to 85 degrees. Okay. The current temperature is only 40. Right. So you need to increase the temperature. So if you just control it by a K value, so there's a difference, right? You need to pull up something, but you only have a K value, a constant value. Then we call it proportional. Okay, so this one, then you turn on the heater to heat up, right? If right here, your temperature right here is actually 100 degree F, then you are actually, you need to drop 15 degree F. So it's a proportional control that actually is called P control, okay, P type control. And you may have this, you may not have, you may have don't have this, okay. So you have the P type control. So now P type control is proportional. It takes time, but there's no buffer. So it's very sensitive, and it actually will have damping. So P type control, the problem you have damping. Okay. And you want to control to 1, but they may have a system gap over there. So you have damping and may have a gap. Both have that. Okay, so that's a problem about this P-type control. Okay, so because you don't want to have a damping, so you may want to add the integral part there to smooth things out. Okay, then you get this I control, PI control. Okay, so if you add the integral part there, integral over time. So integration actually means averaging. Okay. And it also is a high frequency, actually is a low pass filter. Okay, low pass filter means that in the frequency band, you will cut off the high frequency. You just save the low frequency part. That's the integral part work. Okay. So then you will have, you will remove the damping portion. Okay, you will remove the damping portion. Okay, but it actually will slow down the control. Okay, so you slow down the control. Now, and then people may also add the D control there. So if we don't add I, we only add D, then it's a high pass filter. So the low frequency one, it will be filtered out. So high frequencies tend to move faster. But the problem is that damping may become even worse. You pull up faster, but you will have maybe more obvious the damping here. And the gap is actually bigger as well. Okay. So that might not be good. So better one usually is tuning, adding PID, all of them. Okay, 3 possible circuit together. Okay, and then you will create this one. Move up faster and then be able to pull up the ideal level as well. So that's actually an art of how much your proportional should be, how much integral part you need to be, how much differential part you need to be. Okay, so that's the design issue. Okay, and you can only go through a simulator, okay, whatever, and there's another simulator to help you to look at the different parts of your integral part, of your circuit, okay? So you do simulation, you got it. Once you got the parameter of different coefficient and design, okay, then you go to work on the circuit that handle it, okay? So you can have the motor controller, okay? And then you can add the no control. If you have no control, no controller means that you just tune your voltage to control your velocity. There's no feedback control. Okay, you will not track your brain data. Then you can put down positional control to simulate it, to get some velocity. This can be done by doing experiments. Okay, and then you do the derivative part to it. Okay, and then you add the proportional integral controller. Okay, and then PID controller. Okay, whatever, these are something you can do simulation. Okay, here is a simulation result for trajectory control. Okay, what is trajectory control? Trajectory control means that, okay, you do have a robot wheel, right? And if you have higher speed on this one, you will turn this way. If you have higher speed on this one, you will turn this way. So ideally, you will go straight. If your two wheel is moving at the same speed, your car should be go a straight line, right? But in reality, no two wheel in your car, if they are self-driving, okay, they are self-driving, okay, if they have their own drive, then these two wheels may move at different speed. So you need to have a controller to keep your left motor and right motor to be at the same speed, so they will go straight. Okay, that's some control problem. Okay, so that you can do the PID control on it as well to tune the velocity based on the kind of velocity loop that we had before. Okay, this different one. So you tune each other one to make sure you go a straight line. Okay. Okay, so this is the so-called low-level control. Okay, low-level control. So low-level control is not as much of a computer like a high-level control. Okay, high-level control actually is a computer, even AI job. Low-level control is an electronic circuit. So this is a controller. Actually, we can do simulation, okay, and come up with a system diagram, do simulation, okay, find out the key parameters, okay, and then design the loop, okay, design the loop, and then do simulation on it, okay, and then, okay, whatever, okay, and then you actually have look at the real response from oscillator, okay, whatever. Okay, this you finish that's the same you finish the feedback loop. Next one, you want to build it, right? You want to build it. Let me see. You want to build it. So to build it, Okay, I'm sorry, this is the second. To build it, you have a few approach, okay? You have a few approach. Because you have three parts, you have the proportional, you have the I, you have T, right? So these three, you can use RLC circuit, the resistor, the capacitor, and also the inductor, okay, coil, to build RLC circuit. That's the old days solution, right? And then you can do integrated circuit filters, analog filter to design. Okay, analog filter. You can also build digital filter to design it. Okay. So if you do digital filter to design it, that means the whole loop need to be built in a digital format. Okay. So here this is beyond our scope. This is not computer science. Okay. So I just work up to this point. It is a double E work right here. Okay. To design this PID controller. And the mechanical part, like the motor, that actually is ME work, okay, mechanical engineering work. So that beyond our CS people's need, okay. We just touch base a little bit over there. So next one is the finite state machine control, okay. So finite state machine control, this is high level control, this is not low level control, okay. So you high level control, you may have a loop, okay. You may have a loop, and you may use a computer. You may use AI to control it. You may have computer to control it, CPU to control it. You may have AI, you may use a GPU to control it. That's up to you, okay? But you can also use a simple finite state machine to implement it, okay? So this finite state machine can also control the PID controller that we have. You can be using the FPGA approach to do it, okay? So nowadays people talk about AI processor. You still can use the ASIC chip design, FPGA technology, or GPU or CPU, okay? There are many different technology options, okay? This PID, if you do digital, you can use FPGA, okay? And I talk about it, you can also use a traditional RLC circuit or analog filters. We have different approach, okay? And let's look at high-level control using the finite state machine here, okay? That's the chapter here we have. So this one, you do finite state machine control, okay? First thing, you need to come up with the finite state machine state diagram. So there is a turtle, okay, or a small robot. Okay, you move forward and turn right. So that's assume you have two state, move forward and turn right. Okay. So here you have a robot or a turtle. You move forward, turn right. Just using these two functions, you can go, turn right, and go. Okay. And you can forward and turn right 45 degrees. Okay. Okay, continue one more 45 degrees. Okay, no obstacle, go. Right? That you can come up with a simple finite state machine. This one is in C-like language. Okay. Any questions so far?
No, doctor, we are good.
And this is a finite state machine. If there is no obstacle, move forward. With obstacle within 2 feet, turn 45 degrees, right? And turn until there's no visible object, right? So this can be used for iRobot, a simple environment. Of course, the iRobot's state machine will be much harder than this, okay? Will be much harder than this. But here is a what? Design zero, okay? Most simple one. You can do that. So this is actually just a simple example. we want to show you how finance state machine work. Okay, so you can make the finance machine actually a little bit harder to be able to locate a repo. Okay, so whatever. Okay, similar to previous one, just more complicated. Okay, you wonder if you actually have obstacle. Okay, and you will scan for the ball or whatever. So what if the robot has trouble approaching the ball? You will compute it, okay, and align the ball, okay. So this is another finance state machine that will do it, okay. The algorithm you will control, use the IR sensor and a lot of things to work it out, okay. So then you actually have a camera to sense the image, feedback to finance state machine, okay, and then drive the motor, okay. So that's something you can build. Okay. Anyway, that's a system development stages. Okay. And you, of course, in the middle, you may change your finance state machine setup. Okay. So this is only an example, but right here, we don't go through the details. Okay. Not too much. Okay, then we teach you Python coding, then and the FPGA implementation of the API controller. Okay. So first thing is that you need to come up with your equation. Your equation maybe originally is analog RC circuit type, okay? But you need to convert it to a discrete PID equation, okay? That you convert analog signal to digital, and then you convert digital to analog to control the voltage, okay? And then you have a discrete and digital PID design, okay? Then you have a PID equation. This one is the analog one. You convert it to a digitized equation. Okay. This you need to depend on math, how you can do that. Okay. To get a digital equation that's equivalent to analog. Okay. That's a double E work. And then you set up the coefficient and different step. Okay. And use that coefficient. You come up with the register transfer level design for a PID controller. Okay, then it becomes a FPGA design project. Okay, then design an FPGA for it. Okay, whatever. And then look at the timing diagram. Okay. And timing diagram, whatever. And then you will design an FPGA then that will work with your robot. Okay. Traditionally, you use a RC circuit and this analog filter. So the same design can be done in this way, traditional way using electronic component, or you actually use a digital filter. Okay. But nowadays people do use more digital than analog anymore. Okay. So this just solve you the equation, how you come up with the system response that's needed for your PID equation right here, this one, this circuit here, okay? Come up with the IOC parameters. If you use the analog approach and then doing experiment, okay, about how the PID work, okay? Keep tuning, okay? There are a lot of problems there, whatever. These are double E work, so we don't spend too much time on here, okay? Just give you the idea how other people work. Okay, and then we got the state machine working, okay? Loop working, low level control working, high level control working. Last one, you need to look at how you build a mobile robot. Okay. Mobile robot. And then your different part, perception, okay, sensor, okay, connect with the internet or global chip positioning, whatever. your rangefinder camera, okay, whatever, everything. Your response system, your control system, okay, how you should be putting everything together, okay, in the system view, how planning should be done, how control should be done, how physical robust environment should be, okay, how is the perception, how you take the camera in, how you localize it, okay, whatever, these several things. And then after that, you start to look at your configuration space. Okay, and the constraints, developing the mask to control it. Okay. Okay, so there is a disk rolling on the plane control. You come out with different equations to control this disk on the plane. Okay, and there are a lot of equations and things you need to move on. Q means different control variable that we learn from the modeling. Okay, whatever. There are so many maths you need to do, and then you come up with some constraint and working on it and modeling it. And you come up with the system variable for unicycle. Unicycle is only one wheel, okay? That's the disk on the plane, okay? That actually is this disk on the plane. It's a unicycle, single wheel control, okay? And you come up with your system variables, whatever, kinematic model, okay? And then you find out the control loop variables and then design the control loop, okay? And then this work on unicycle wheels, okay? Then you may have a 3-wheel synchronized drive mode, okay? You may have bicycle 2-wheel, okay? And 2-wheel has 2 wheels equation, okay? Tricycle 3-wheel, okay? So you actually have different formula, okay? So here just go through different possible modeling and their dynamic modeling at system level, okay? How many wheels they have. And then we can create a mobile robot. So this is the last chapter we have, okay? The detail, you have to study the math. Any questions so far?
No, doctor, it's
No,
very
it's okay.
interesting topic.
Okay, so this one is the last chapter we have, okay? So this last part of the tutorial is actually talking about how you form the control at the system level and the low level, okay? And then also what is the feedback response, and also how you build a finite state machine, okay? Okay, so if you actually okay with your project and you have something else to do, you can leave right now, okay, if you have to that. If you actually still want to listen to me, okay, I can talk about overall how to build your career in AI, okay, if you are interested. But you have your own work to do, you don't have time, okay, you just want to hear about the robotic course related things, you can leave, okay. Let me pick up some material, okay. Let me pick up some material, give me some time, okay, let me see. Let me pick up, okay, right here, okay. First thing is like, what are the jobs available in the market, okay? What degree you need to get, and how you actually build up your career to be able to match it, okay? So right now, okay, right now you have a lot of jobs you can find in the job market, okay? Let's look at the application side. Application side, you may go to Wall Street to do high frequency trading. You may go to Google to develop a search engine or ChatGPT. That's application, right? It's application. So that's actually some domain field knowledge may be needed. And you can work on the modeling and research. then you need to have AI knowledge, algorithm, and machine learning. Okay, that's modeling. This is more math. This one you need finance or business idea. Okay, or double E. And then you may be a coding part. This is a typical SWE job. No matter what people's project, they just tell you to write some code. So a lot of CS people are working on this software engineering. Okay. And there are people who can do hardware acceleration, FPGA, or even GPU design. Okay. So AI career or software career right now primarily is for different level and domain. A lot of CS people focus on this software engineering. Okay. Okay, and then this different domain, you may have different kind of degree. Okay. So if you go to Wall Street, you may have an MBA or MFE, Master of Finance and Financial Engineering. Okay. If you work on this modeling and AI algorithm, you may work on math, applied math, or statistics. Okay. If you work on this software engineering, you may be data science, maybe CSE, computer science or engineering, maybe CS. If you work on the GPU or FPGA, you may have computer science and engineering degree or X degree or double degree or computer engineering degree. Okay. These are different degrees you need to have. Okay. And you need to prepare yourself to be able to do it. Let's look at okay. Let's look at the program that my son go to. Okay. This one is UC Berkeley. Okay. MET program. So this one you can search from internet. That is a Berkeley program or MET program. Okay? It's a fast track to become a CEO engineer. Okay. I use this one as an example because it is the most complete career building program. Okay. Because you need to get 2 degrees in college. So you will get a business degree from Berkeley Hutch School of Business. Also, in the engineering school, you need to get a each degree, including double E and CS. Okay. And there are a few programs right now in different universities that providing this dual degree possibility. One is Berkeley MET. Okay, it's Berkeley. And then the other one is UPenn MNT. Okay, UPenn. And you can also go to MIT to work on X major. And then double major with Sloan School of Management. Okay, so you have MET, MNT, and MIT. 3 possible ways that you can work on such program. Okay. So anyway, it's build up your academic entrepreneurship. Okay. So basically, you need to have math. Okay. Build up your math. Math is the key. Okay. And then use CS to implement whatever mathematical modeling you have. And then go into different application field. Okay. This is how you build up your career nowadays in AI or in computer science. Okay. So next one, your math. Okay. How much math you need to learn? You need to have most of the courses that right here. Decreased math. Okay. Linear algebra. Okay. Calculus, multivariable calculus, differential equation, real and coupled analysis. These are core CS for engineering school. Okay. Beyond that, if you want to do AI, you also need to have probability, statistics, random process, dynamic system, optimization theory, machine learning, neural network, okay, whatever. So you prepare your own self in math. Next one, you need to have the information system knowledge. That's your CS degree. Okay. Then you work on device, IC, board, software, and business websites. Okay. So that's the way you build up your career. Okay. And business at different degree. Okay. I don't emphasize on business side. Okay. So 3 possible program. Okay. This 3 possible program. Okay. And then let's look at the Berkeley side. Okay. So Berkeley, if you get into Berkeley, and then they will have introduced to computer science. So you learn Python, Java, C, C++, and assembly. Okay, these 3 courses in one series. They call it Introduction to CS series. Okay, so Python focus on AI, computational thinking. Okay, Java focus on data structure and algorithm. Okay, this is typical DSA course, data structure and algorithm. C, C++ focus on machine learning, and they also teach you RISC-V assembly. Okay, so this is introduction to CS. Okay, and some students, they come in without experience, so they can take their own course, data 8, data 10, CS10. Okay, and each major you also require to have the multivariable calculus. That's a required course. Okay, and then in addition to this introduction to CS, they are major in EECS, right? So there's another part that's introduction to EE. Okay, so the introduction to EE, you actually need to take EE 16, that including the circuit design and also machine learning. Okay, and then you take the EE 16B, that has robotics and also communication system. Okay, and then you also need to take a decreased mass for probability and decreased mass. So this is finish your lower division in about 2 years. Okay, so the you are yes.
One question: do they request a higher score in GMAT GRE, or it is very hard?
No. GRE not required. GRE not. This is low division. This is 4-year university. This is not even master. I'll talk about master later. Okay, I'll talk about the master program later. Okay, so this is East major, right? This is East major, but you can also, the CS student also require this. Okay, this both CS and EE need to go through introduction to CS and introduction to EE. Okay, not only for ECS but also for CS. Okay. Anyway, you finish this one, and if you move on to higher division, that's junior year and senior year, you want to focus on AI track, right? So you need to take the math course that I talked about, the PT3 multivariable, okay, linear algebra, differential equation, probability, statistics, and random process, optimization theory. So you can take the introduction to AI, machine learning, and deep learning in neural network, right? After artificial intelligence, they have 2 semesters of robotics. And before you take these 2, you also need to have signal and system in EE and DSP, and maybe 280 for computer vision. So you see, there's a lot of preparation work before you come to this robotics course. Okay, Our 8-week course is not enough, okay? Definitely not enough. We talk about a lot of topics actually, including everything here, right? But you have to pick up the courses if you do not have enough background to work on this field, okay? General CS and EE, they have millions of courses. You took whatever you like, okay? The one with Smiley is what my son already finished, okay? The one with Smiley is the one that my son already finished. And then you can work on the business course. This is another part of the program in the MET program. So this is a typical business school one. If you want to go to finance, computational finance, you want to work on the Wall Street, right? You need to at least work on the accounting, finance, these 3 courses, and macroeconomic, okay, business analytics, right? Other things are more like business related course. But if you want to work on Wall Street, these are minimum that you need to pick up. So this how is the MET program work out, okay? And then stats. If you want to learn machine learning, some stats courses very much needed. So again, the Smiley part is what my son already finished, okay? Okay, whatever. So that a lot of work you need to work on, okay? That's a lot of work to work on. So for master program application, okay, let me talk about this part. And the interview for job, okay, let me talk about this part now. So let me pick his master application form, okay. Stanford, no, let me see, not this one. Okay, Stanford application. Let me pick his Stanford application. No GRE needed. Okay, nowadays it's almost test optional or test blind. Okay, and in fact, you know, we are in California, right? California is very freestyle. So I think most California school right now is just test blind. Okay. So you have your graduate study application in Stanford. So, okay, anyway, the background information, okay, that's actually is a personal, okay, it's the GPA, whatever. So he lists down his he right now is junior. Actually, he will finish his college in 3 years. Okay, let's look at how much he transferred from high school. He started his Berkeley with 113 semester unit from high school. He has 16 dual enrollment, 18 AP. So when he transferred to Berkeley, he already got a senior standing. Okay. So in high school, he actually accelerated himself a lot. He took a ASU math course for college. He finished all of the college math from ASU. He also took a Foothill College programming course for C++3. So he finished 1, 2, 3 in C++ and JavaScript. Okay. And then basically finished the DSA, data structure and algorithm, in high school. He also had a user called Go level. Okay. So basically, what I want to say is that in high school, he prepared himself well. Okay. And within 2 years, he take another 70-something unit. Semester unit, okay? It's semester unit, not quarter unit. So he already 196 in 2 years, okay, in 2 years, including 113 from high school. Okay. So let's look at the ASU transcript, okay. What I want to show is actually the math course that he took in high school. Because most of the math course that he took is from ASU. So this one, okay, this one show his math course. Oh, this one not the final one. Let me show you something that final, okay. Screen, there should be a final one. Completion, this one. Okay, official transcript. Okay, this one. So he take discrete math, okay. Here he actually in ASU he finished discrete math and also digital design, differential equation, linear algebra, right? And he finished AP Calculus BC in here, AP Stats, also from his AP courses, okay? And also multivariable and multivariable calculus, and the calculus also from ASU. So many courses from ASU, he finished that, okay, over there. Okay, let's continue his master degree application, okay. So in addition to the courses that he take, some other things need to be prepared, okay. Research experience, okay, research experience. So he worked on with a professor in freshman year at Berkeley on natural language processing, okay. At the same time, he also worked with a professor on self-driving car. He worked on the computer vision part. So what I want to say is that in university, you must find time to work with your professor for guided direct research. This kind of direct research will help you to find internship, and also will help you to prepare yourself for graduate school. And last one, he worked with Ion Stoica, okay, a very famous professor on the machine learning and modeling. Okay, this one I'll talk about it more. Okay, this one. Why this one is important? First, let's talk about this Ion Stoica professor, okay? They have a computing lab called, this one called Sky Computing Lab. Sky Computing Lab is also called Rice Lab, okay? So this lab working on machine learning and actually the infrastructure for what? For machine learning, okay? So this person is Professor Ion Stoica. So let's search YouTube, okay? So this professor already technology transfer four possible companies, okay? So the recent one is Anyscale, okay? So the company he transferred to actually in the university including Databricks, okay? Anyone hear of a Databricks before? It's an important AI framework, okay? And recently is this one called Anyscale. So this Anyscale, this company, okay, this company Anyscale is to use what? use one CUDA, okay, NVIDIA GPU, and then run maybe 1,000 LLM. Okay, so this array infrastructure is over here. This GPU is over here. CUDA, okay, NVIDIA is over here. OpenAI is on top of it. So OpenAI use the array utility, use the GPU. Is that okay? So this
Yes.
is how important this thing is. If you want to go to some company like OpenAI, or you want to go to somewhere like GPU, you need to work on the system for AI. You must handle multiple machine learning model and being able to go there. Okay, so let's look at my son's application one more time. So this is the project that he worked with, okay, for 2 years. Now let's look at his application, okay. So to apply for master program or PhD program, he need to have some publication. He already have 5 application, okay. Anyway, that's not important. Let's look at his.
He worked with LoRaWAN?
Yeah, his
Nice.
his recent publication that the LoRa. You know the LoRa, right?
Yeah, Sigfox, LoRa, NB-IoT,
Yes.
Yeah.
He recently, this paper from Stanford and Berkeley, he's one of the authors.
Nice.
Okay, so he's very fast moving. That's why I'm showing his resume. Okay, key point right here. Okay, he will be intern for any scale in coming summer. Okay, he will be a intern for NVIDIA in coming spring, coming one. Okay, he just got it. His tool is future. Okay, not happened yet. But before that, he worked for IMC Trading. This is finance, right? It's actually in Chicago. Okay, he worked on this for finance system, for trading system, software engineer, and he has this one, Skylab. Okay, employee for cell phone platform, backend engineer. This is freshman internship, right? So what I want to see is that these are major ones. These are the major ones. The internship. Okay, let me show you his internship roadmap. Okay, this one is the major one, so you don't see how many interns he goes through. Let me show you his preparation for internship. So it's not only one internship that bring him here. Okay, it's not only one internship that bring him here. Let's look at his show resume right here. Okay, so he got into this Berkeley MET with many scholarship. Okay, of course, whatever national scholarship. Okay, let's look at his show internship. So he started with NASA internship. This is senior year of high school, and also Berkeley Skytech. No pay. Okay, this one no pay. And then venture capital scout, no pay. Okay, Coyard Venture, no pay. Okay, so you see this already 1, 2, 3, 4 no pay internship, right? So what I want to emphasize that don't overlook those no pay internship. They will give you experience. When you talk about it in your job interview, they know that you already have some experience. If you never take internship, don't have resistance on the no pay one. They will build up your career. Okay. Then one from his coding club, contract software engineer. I think this one low pay. I should say low pay. Low pay means under $30. Okay. No pay means that below 20 or less, or even no pay. Okay. Okay. 50, I think, is already high pay internship. Okay. 50. So this one, Capital Summit, is invitational. Okay. Invitational internship training. Okay. Capital One. Capital One is also a good company in finance. Then his first pay one, summer of the freshman year. Okay. This pay job, $50. This one already $50 freshman year. Okay. So before he got it, he goes through several no pay one and then got the first one in freshman year, freshman summer. And then this one is sophomore summer. This one, $85 with 50,000 sign-up bonus. For the fall summer, he earned about 50K. A lot, right? This one a lot. And then he work on this coming spring, and he will work on these two internships. What I want to say is that this whole thing is build up. You don't jump from 0 to here. You won't, right? You won't. You have to go through some of these. Maybe not as many as him, but you need to go. He's just a junior year right now, okay? He's just junior year. His achievement, I think, that overpassed a lot of senior students already. He's graduating this coming spring, okay? This coming spring is graduating. And he's honor, okay, whatever, tons of honor. Major important is this Coinbase club. It's very famous, very hard to get in. The whole Berkeley, maybe only 30 people. This one. Blockchain club. Berkeley blockchain is #1 in US. Venture capital club, you see. So club is very important because you will know about a lot of people. They will, you may throw maybe 20, 40 different internship application, but maybe no response because nobody refer for you. With the club, if there are some senior student or already alumni, they help you to pass your resume to some company. Your chance to get interviewed will be higher. Okay, so let's see. First year when he applied for this AppLogin, he told me he goes to 50 resume. He sent out more than 50. Okay, and in fall of the 21, no response. He only got a response from Amazon. Okay, one response from Amazon, maybe in October. But he didn't get it. Okay, he didn't get it because people look at it. He's only freshman, so not even pay attention to it. Just one run and out. Okay, one run and out. Not even doing technical. One run and out. And then this AppLogin come in December. So he spent his whole December, Christmas time working on LeetCode. Okay. So December 29, he got an interview. During the winter break, okay. And he got it. He got his first interview. What I want to say is that don't give up, okay. He throws many got a lot of rejection. Okay. Since in the second year, I think this year he improved, okay, because he has some experience. So he get more invite for the internship interview. Okay, I think this one more. Maybe he goes to 10+ interview this year. So his chance much better. And he pick a better one. Okay. And then this year is much easier now. Okay. This one, someone invite him. This one also someone invite him. This one, any scale is actually related to the research, right? That's his professor. That's what I should say. You know what I'm saying? It's what his professor's company. So this one's super easy now. So you build up your career by your research, your no-pay job, step by step, okay? And then you also need to get involved with different membership and project and try to generate more publication or research with your professor. That's the way you build up your career, okay? And it's not only benefiting your job searching, but will also help your application, okay? Will also help your application. So when you apply for master, so he probably after this master can apply PhD program, okay? Up to him, okay? I'm not forcing him to do anything that he don't like, okay? So there, okay, let's look at the application. There's a statement of purpose you need to work on, okay? So in here, he pretty much talked about his research experience and future research, okay? So he talked about his large language model and LLM, whatever, and LoRa, okay, whatever he worked on. And then how you help the community. This one, community statement, this one is for Stanford only, okay, this one Stanford only. Berkeley need you to write a historical statement, okay, historical, how you do research before, something like that, how you grow up. And principal data field, okay, AI system, whatever. So that's about his application to master program, okay? Okay, other things I think not important, just sign up. Okay, here I'm going to open for question. Any question about this course or the master application, college, PhD application, or job search? Open for any question you have.
Oh, for me, it's okay. Thanks so much for explaining all details of your SAM application. Very interesting, yeah. And for the entire course as well. It's
Okay,
a lot of
sure.
information, but it was very good, yeah.
Yeah, it's an 8-week course, okay? I cannot be complete, right? We cannot. Compared to, Berkeley, I told you it's a 2-semester course. And before the 2 semester, they already build up their career in the AI track, right? That's hard. That part is very hard to replace. But you cannot always compare to Berkeley student, right? Or MIT student. That's the wrong way to compare. It's hard, much harder. But one thing I want to say is that you need to get the right direction, okay? You need to go through the good fundamental training. What I want to emphasize is that get the right courses to prepare your career. If you go AI, you need all these, okay? You want to do DSP or you want to do computer security, that's a different story. You pick other course. If you want to do AI, you need to prepare these different courses before you can really be a good AI researcher or a candidate to find a good job, right? And I showed my son's record just to show you how he built up his career and being able to land a internship at NVIDIA and also the Anyscale, the infrastructure of the AI part, right? In the future, he may work for Wall Street, may work for OpenAI. I don't know. I really don't know what his career goal. But right now, he's building up his career in that direction. Okay, a lot of work. Okay, a lot of work. You see how many courses that he took before, right? He actually took a lot of courses, and right now his GPA is 3.97, 1 A minus only at Berkeley. Okay, Berkeley is killer. Berkeley is the #1 school that will fail you. Okay, the average East GPA is 3.4 when they graduate. Their bio department maybe 3.08, something like that. Okay, some sort of very low GPA school. Berkeley is famous for it, for deflated GPA. Okay. Berkeley is famous for deflated GPA. That's something you need to prepare for yourself. That's the purpose I bring up this, okay? Remember what courses you need to take before you move on to the next level. If you don't have the machine market optimization theory, it's very hard for you to do machine learning, or you take the machine learning, but it's too soft. If it's too soft, that's not enough, okay? That's not enough to land a good job. So you need to go through little bit math training before you go to here. You need to finish the red one, the math one, before you go to the blue one for CS and black one for double E. Okay.
A quick question. What means deflat GPA?
Deflated GPA means that everybody is very low.
Ah, okay.
Compare to Harvard, say Harvard's GPA is more inflated. Okay.
Yes, sir.
Harvard is more inflated. The GPA is easier to earn.
Hello, Professor.
Yes, I mean Harvard's GPA is easier to earn. You see, it's called Great Depression. Very low. You search internet, you see it, okay? And if you search for Harvard, they tell the different story. It's impressive. You see, you can search. It's Harvard GPA, about 80% of the GPA receive A. You see, very easy to get high GPA at the Harvard or Yale. You know what I'm saying?
Okay.
It's a different school. Every school are different. Okay. And if you want
Professor,
yes.
Could you please include those slides which you just mentioned about the different tracks? Could you please include that in the Blackboard? Can we get?
Different track?
Yeah, these information.
For Berkeley?
Yeah.
Berkeley has 11 track, okay? Berkeley X has 11 track. So if you are interested, you can do EECS, UC Berkeley. Okay. EECS, new student information session. Every year they welcome student. Okay, they'll talk about this one. Major information session for this apply to actually at the meeting. EE, okay. And then they'll let me search for you, okay. Certain time in here they'll talk about it, okay. So they talk about what is the EE, what is CS, right? Different field. So basically, okay, Berkeley X has one advantage. It's like they are all you can eat school. What does it mean by all you can eat? So if they have 300 courses, okay, if they are 300 courses in X, let's assume here you have 300 courses in X. As long as you are Berkeley X student or CS student, you can pick anyone to graduate. They don't force you to take any course. If you are the 300, if you are the X student or CS student, you finish the lower division, introduction to CS, also introduction to double E. That's it. That's all the requirement they have. After that, it's all you can eat. All you can eat means that they don't care which one you take. You take whatever you like to graduate. Is that good?
That's thank you.
That's very good. So there's no track problem, okay? Track is only to show you, to help you to find job, okay? So you see this chart. This chart is the lower division, you finish the introduction to CS, introduction to double E. That's it. That's all you need to do. After that, 11 track. So there's an artificial intelligence track, computer system track. My son focus on this one.
And then robotics.
And this one.
Robotics.
Yes. and maybe a little bit of this one.
Oh,
Okay.
electronics.
No, computer graphics and vision.
Mhm.
And also some of the RISC processor, because you work on processor as well. Okay. But because it's all you can eat, so you can take whatever you like. Okay. And in a way, if you are interested in the track information, what tracks you study what, Berkeley is not the best site, okay? Because they are all you can eat, so they don't give you the information. You need to search for yourself. A better school is the UC Irvine Computer Science. It's good you meet with this one, okay? Let's look at Irvine's CS. There's a simple program. Okay, let's look at the requirement first. So the requirement is a major requirement, okay? So let's look at the computer science requirement. So computer science requirement, they have lower division requirement, okay, that's of course upper division. So upper division, you can select embedded system track, algorithm track, okay? And then here you will see the different track, bioinformatics track, general CS track, information track, okay? There are 11 track. They list down all the track required courses. Is that okay?
Yeah.
If you are interested, this one is UC Irvine. They give you more. Now look at the sample program. Sample program show you how they spend their 4 years. And general CS is that you finish the required course and then elective. So it's also all you can eat. You pick one of the 11 track, and then after that, it's all you can eat by yourself. Is that okay?
Yeah, thank you so much.
So this school is a better guidance. But the fundamental part is that you need to prepare yourself for the job market that you want to go into. Okay, that's a key. Very good question. Okay, let's look at actually undergraduate program they have. This is computer science, right? So let's look at undergraduate major. I'm sorry. This is not what I want. Let's go to the CS school, okay? So department of CS. Let's look at this one, okay? They are school of CS. They have bioinformatics minor, BIM major, CSE major, CS major, okay? And so if you want to do CS master here, A undergraduate major, okay, totally A undergraduate major, 3 or 4 master major. So a lot you can choose. Even network system master, okay? So if you want to take another master, this is a good school to go to.
Hello.
Yeah, for
And also very easy to find job. Any other question?
thank you
Yes.
so much.
I have a question. So
Yes, go ahead.
where is a good place to like look for internships and these entry-level jobs that, you know, computer science masters with like software engineering and a little bit of AI experience is used?
You can okay. Internship you can find a lot, okay? Best way to do it, I would say this one, okay? I would say first thing you go to summer internship level FYI, okay? So this one show you all how much money they make, right? So starting from 160 rating trading, right? It's a financial thing at Chicago, right? This is probably the crazy cow, okay? You need PhD, okay? And then housing, whatever. Okay, this is $150, $60. And then you move down to to somewhere more reasonable. Okay. So 70 already very high. There are some companies, these are already very high. Typically above 50 is very high. So somewhere like NVIDIA, okay, whatever, they all have internship. Okay, these are different companies. You search for the price range you can then, okay? You know what I'm saying? So go down to around 60, 50. Okay, around 50, these are more realistic one, okay? It's already very challenging. This is 50 something one already very challenging. Okay, these are, I say that up over 50 are high paid one. Microsoft only 52, okay? Actually, okay, and then sub 50 is easier. Sub 50 is easier, okay? So this is a good source that you find a company that offer the summer internship. Then you go to the other website to search for what they have right now. There are a few places you can find. LinkedIn, okay, and then Glassdoor, okay. Glassdoor. There are some other locations you can search for. But if you apply through these different websites, that's slower. LinkedIn, okay, oh, that's slower. A better way is still through your reference, your personal reference. So you need to build up your relationship with professor, with a club leader, with your alumni network. That's actually more reliable than just searching from internet. Is that okay?
Yes. Are there like a job fairs at
Their job
Lewis?
fair, I don't know. I'm not full-time at Lewis, but Berkeley, there are tons of job fair every year, like 3-4 times. Lewis, you have to check your career office.
Yeah, Lewis we have as well. Yeah, we have
Yes.
career. I think it's once per quarter or per semester. I do not remember. And
Yeah.
I share one that is built in. That is built in. That is Chicago, Seattle, LA, and I send one that is in Chicago. It's a very good one. They have a lot of startups and yeah.
One good website is this one called Call Signal. This is Call Signal. You kind of take some exam here, okay, and you got some score, and then they are participating company like Uber, Meta, this one. These are participant company, okay. So this is a participant company. Once you have a score, you can send to them right away. They will consider. Is that okay? This one called Signal. Call Signal. There are a few companies, several companies, okay? Their company, you need to search their company section. This company, they support this Call Signal. So once you get a good score, you can send your resume to them. They will consider. Even some company, even just look at the score, they will hire you. Okay. But most of them may give you a good chance for interview. Is that okay? This one. So prepare for coding, LeetCode, and this Call Signal test. Okay, prepare for it. That's one good way to land a good job. Okay. Any other question?
No, doctor, thank you so much. It was very, very informative class. Thank you so much for your
Okay.
time.
I post my Facebook, okay? So in the future, after you graduate, if you still have some question about career or something, you can still send me a Facebook message, okay?
Professor?
Yes?
Sorry to say, I was trying to add your account, but was not like accessible, or it might be.
I respond to you.
Oh, response. Thank you so much.
Yes, I respond to you many days ago. After you send it, I respond you already.
Thank you so much.
But you have to read it, okay?
Okay.
You have to read it. I respond you several days ago. Every student who apply, I actually edit. There are a few students, okay? Some student they edit, many student they edit. I all approve it. Any other question?
No,
Just
doctor,
one
thank you.
quick last one. For our final project, if we
Yes.
choose to build a robot
Mhm.
and record ourselves doing it, do you think the best place to record it would be like just upload it to YouTube and send you a link, or what
Just
would
give
be-
me a link, whatever site, I don't care. As long as you can share.
Okay.
I'm not a YouTube the representative. I don't sell YouTube, right? So any website, as long as it's actually safe, right?
I'm
And
just
also,
asking one question. This is just part. Okay.
yeah, as long as it's safe and I can get the video, I can look at it. That's fine.
Okay, thank you.
No limitation on it. Okay. And if you pack everything of your code, you don't want to send me, you put on GitHub and you want to share, that's also fine. The technical card, the schematic, okay. We are tech course. We use tech tools, right? We don't do it traditional way only, okay. But you submit the data through the Louis site, I'll download them. That's fine. Okay. If you just put the link for GitHub, I'm fine. I'm fine as long as I can download the code. Okay. If you miss the code, I will check with you. Okay. Before I give you the final score for the final project. Okay. Any question? Or if I give you a best score, you can tell me, oh, I forget to upload my code, or this is the link. Okay. Any question?
No, doctor, thank you so much.
Okay. If no more question, that's it for today. Okay. And also wish you good luck in the final project and also future job search. Okay. Okay.
Thank you.
Thank
Thank
you.
you, sir.
And then
Thank you so much, sir, for
yeah,
your
keep in
very-
touch if you
Thank you,
have,
sir.
yeah, keep in touch if you have any question in the future. Okay.
Okay,
Okay.
thank you so much.
Okay. Bye bye.
Okay,
Bye.
thank
Thank
you,
you.
sir. Have a great day.